So now let us look into various network architectures. So any network that is built using the client server architecture, the devices communicate to the other devices through a central computer is referred to as a server. So this is that server. So the server is a terminal with high processing power, so which provides services for the other computers on the network, and those other computers which take the services from the server are known as client 1, client 2, client 3. Basically they request for data, and then our server serves the data from the database, that to the selected data only, whatever data they request. If client 1 requests a certain amount of data, they will send a certain, the server will route that specific data to this client 1, and then client 2 and client 3 as per their requirements. So now what will we do is, so we will look into uh, the concept or the methodology of how this request and a reply or request and a response interaction takes place in a client and then server. So normally the operations, I just want to explain the operations that takes place in between this client and then a server. So how does it how it happens? So basically these operations we call it as primitives. The correct terminology for these operations are primitive. So these primitives might be used for a request reply interaction in a client server environment. So let's illustrate this using a sketch. For that we are going to sketch a simple protocol that implements the service using acknowledged datagrams. It's acknowledged datagrams. Okay, acknowledged datagram service is the one which we are using. If you do not know what I'm talking about, what is acknowledged datagram, you just watch my previous video. So there you will find it. We have discussed about the different services there. Okay, so now what is going to happen first? First, the server executes listen. First, the server executes listen before you request something. First thing, the server executes listen to indicate that it is prepared to accept some incoming connections. That's the first primitive. First primitive is listen. So a common way to implement listen is to make it a blocking system call. After executing the primitive, the server process is blocked until a request for connection appears. So then next thing is the client. Here is our client. This is our client mission, and this is our server mission. As usual, the client mission consists of a kernel, then protocol stack and drivers, and it will be with Linux operating system. And then this is the client process where it's calling system calls, and server mission, it could be our client mission could be a Linux OS, or it could be a Windows, or it could be a Vista, or it could be anything. Whereas but server missions normally comes up with a Linux kernel, and then any kind of Linux distribution. It could be Ubuntu, or it could sorry it could be uh, CentOS. Okay, so now the client process executes connect. Here it is, connect, to establish a connection with the server. Okay, that is our first primitive. So the connect call needs to specify who to connect to. So it might have parameter giving the server's address. So the operating system then typically sends a packet to the peer asking it to connect, as shown in the infographic which is displayed on the screen. So the client process is suspended until there is a response. So then once it gets connected, when the packet arrives at the when the packet arrives at the server, that's through the connection request from the client, the operating system sees the packet. It is requesting a connection, so it checks to see if there is a listener, and if so, it unblocks the listener. Then the server process can then establish the connection with the accept call. So using an accept call, accept a response, it accepts the connection request from the client mission. The server mission accepts the connection request from the client mission. So this sends a response to back to the this sends a response to back to the client process to accept the connection. So the arrival of this response is then releases the client. At this point, the client at this point what happens to the client? At this point, the client and the server are both running, and they have they have established a connection. That's it. At this moment, they have established a connection. So obviously, the obvious analogy that we can take here, the obvious analogy between this protocol and real life is a customer client calling a company's customer service personnel or manager. At the start of the day, the service manager sits next to his telephone in case it rings. He is sitting next to the telephone means he is he is in a listening state. It's a listen primitive. When it rings, so later a client places a call. Client places a call. It is a connection request. It's connect primitive. Then when the manager picks up the phone, it is the connection is established through accept primitive. So that is the analogy that we can take here. So after the connection is established, what's next? The next step is for the server to execute receive to prepare to accept the first request. So normally the server does this immediately upon being released from the listen. So before the acknowledgement can get back to the client. So the receiver call blocks the server. The receive call blocks the server. So this is how the receive primitive comes. But this happens in parallel with the connection request. When it receives the connection request, at that moment itself the receive primitive comes into the picture. So then once once the receive call blocks the server, then the client executes a send uh, send primitive to transmit the request 3, followed by the execution of receive to get the reply. So the arrival of the request packet at the server machine unblocks the server so it can handle the request. So after it has done the work, the server user send to return the answer to the client. So basically this is a reply. It's a reply. It will send a reply to the client 4. So the arrival of this packet unblocks the client, which can now inspect the answer. If the client has additional requests, it can make them now. So now for the final one. So let's look into a small example that's related to this client server architecture. It's not the exact representation of client connection oriented service, but by and large we can get uh, some information from that. For example, this is the API endpoint. So from this, I want to fetch some data that's in JSON file. Let me execute this. So I have sent a request. So once the request is sent, and then we got the response, but that's what we see here. But whereas behind the screen in the back end, a service, a primitive service, and then primitives takes place, and then because of each operation we could see the final response. How this happens, that we can see if you go here. So this part you can see the event. So first what had happened is socket initialization. So after the socket initialized, it's basically one is in the one part is in waiting. It's basically, what do we call it as, um, one part is listening, and that our server is listening. And then once you initialize your connection request, basically connect a request, when you initialize from your side, then obviously DNS lookup, and then once DNS looked up, then TCP handshake, then SSL handshake, then finally after all these activities accepting the response, and uh, as we have requested a specific kind of information from this endpoint employees, so that has been accepted. Once that is accepted, so then the transfer started, so the response has been started, and finally it's been downloaded, and then it got disconnected. So this is the event. It's a single event, and that is how a service works behind the hood. Not exactly the same that we have seen, it's a different kind of service. However, the process by and large goes similar to the service that we have seen in our slides. And as we have discussed in our layers, so body is the main data, and headers is the one which navigates the data through different layers. So body is 636 bytes, whereas headers is 472 bytes. This is how it works. Without the headers, it is very difficult to navigate that body to the different clients.